Okay, in this video I'm going to show you how to use the quotient rule to differentiate the quotient of two functions. So if I have the function f of x divided by the function g of x, and I want to differentiate it, I take the top function, its derivative, times the bottom function, minus the derivative of the bottom, times the top, divided by the square of the bottom. Okay, so f prime g, the derivative of f over g, is f prime g minus g prime f over g squared. Okay, let's differentiate this function here. So we want to find h prime of x. So what we do is we take the top and differentiate it. Times the bottom function minus the derivative of the bottom times the top. And we divide all of that by the square of the bottom. Okay, the derivative of 2x squared minus 4x plus 3 is 4x minus 4 times this minus the derivative of 2 minus 3x is negative 3 times this. Divided by the square of the bottom. Okay, let's clean up both of these two pieces in the numerator. Okay, so we FOIL this one and distribute the negative 3 on this side. Now we can collect like terms. Okay, so we have negative 12x squared minus a minus 6x squared is negative 12x squared plus 6x squared, so that's negative 6x squared. 8x plus 12x minus 12x is 8x, and negative 8 minus a minus 9 is negative 8 plus 9, which is 1. Okay, so this right here is the value of our derivative. Okay, here's one for you to try on your own. H of x is equal to 3e to the x plus the square root of x, all divided by x squared plus 1. Find h prime of x. Press pause while you work on it. So it's the derivative of the top times the bottom minus the derivative of the bottom times the top divided by the square of the bottom. So now we have to differentiate this 3e to the x plus the square root of x and this x squared plus 1. And the derivative of 3e to the x is 3e to the x. The derivative of the square root of x is 1/2 x to the minus 1/2. The derivative of x squared plus 1 is just 2x. Okay, now we should FOIL this out and multiply this. Okay, so we get 3e to the x times x squared is 3x squared e to the x plus 3e to the x plus 1/2 x to the minus 1/2 times x squared. When we're multiplying two powers of x, we add the exponents. So negative 1/2 plus 2 is 3/2. Then we have plus 1/2 x to the negative 1/2 times 1. So that's plus 1/2 x to the negative 1/2. Then minus 2x times 3e to the x is 6x e to the x. 2x times the square root of x. So the square root of x, remember, is x to the 1/2. So we have 2x times x to the 1/2. We add exponents. Okay, the exponent of this x is 1. So 1 plus 1/2 is 1/2 or 3/2. So here we have this 2x to the 3/2. Okay, we should now collect like terms. Okay, here basically only the 1/2 x to the 3/2 and the minus 2x to the 3/2 can be combined. And so that leaves us with a negative 3/2 x to the 3/2 there. The last thing that I want to do is, I can't really factor out any numbers here, but I don't want to have this negative exponent here. So I'm going to make that a positive. I'm going to get rid of that by multiplying the top and the bottom by x to the 1/2. So the reason I chose x to the 1/2 is that when I multiply this x to the negative 1/2 times x to the 1/2, those two are going to cancel out. Okay, so basically, to get rid of a negative exponent, you're going to multiply the top and the bottom by x raised to the positive of that. Okay, so what we get, we multiply x to the 1/2 by this term. So we have x squared times x to the 1/2 is going to be x raised to the 2 plus 1/2, or 5/2. We have 3e to the x times x to the 1/2, so 3x to the 1/2 e to the x, minus 3/2 x to the 3/2 times x to the 1/2. So that exponent there is 2, because 2 is 3/2 plus 1/2. And next we have 1/2 x to the negative 1/2 times x to the 1/2. So that exponent, negative 1/2 plus 1/2, is 0. So that leaves us with just 1/2. And then minus 6x e to the x times x to the 1/2. Well, that exponent of x, we have an x times an x to the 1/2. So x to the 1 times x to the 1/2 is x to the 1 plus 1/2, or x to the 3/2. So this is your final answer. Okay, I want to share with you a little thing that some students find helpful in remembering the quotient rule. And it goes like this. Okay, so for the record, I think that this is easier for me to remember, so I just use the quotient rule itself. But since some people might find this helpful, I'll share it with you. Okay, so low, D, high. What that means, low refers to the denominator, high refers to the numerator. So low, D, high means you take the bottom function times the d in front means the derivative of. So low, D, high means bottom function times the derivative of the top, minus high, D, low means top function times the derivative of the bottom function, divided by low, low means the bottom function times the bottom function. Okay, so low, D, high minus high, D, low over low, low. Sounds very goofy, but again, it might help.